Oh, okay.
Keller and Mailer.
Down to Carboff and get a cup of coffee.
Okay, sir. Barbara. Barbara? B-E-R? Yeah.
Wedding anyway, yeah, they're still setting up.
Welcome, everyone. Welcome. Thank you all for coming out bright and early on this lovely Saturday morning to the final finale, dessert, festivity, and more of Science and Food. So as many of you know, this event has only been possible due to the help of a large number of people. I'd like to call it especially some of our support staff in the Department of Integrative Biology and Physiology who've really gone above and beyond their call of duties. Grace Angus, Annette Clufus, Lisa Marin, and Sheena Sanchez, as well as Feely, Lee, Michael Sohn, Larissa Zhou, who've really been integral to making this all happen. And of course, yes, a round of applause. And of course, as many of you know, all of these chefs who have participated and taken the time out of their busy work schedules to come and lecture to us, both in the course and in this lecture series. And in addition, numerous sponsors as well. In particular, today, we have prizes for the final projects from Breville, Umami Burger, as well as Whole Foods. And in addition, some tastings that you'll be sampling outside. Thank you to Hershey's and Emberry. So, the timeline for today is as follows. This is the brief welcome that's happening now. We're going to hear from Sherry Yard about Poof, there it is, and then a little bit about thickeners and mouthfeel, which I'll tell you more about. That's a bit of course content on how we can tune viscosity. Jimmy Shaw will then tell us more about his approach to thickening in traditional Mexican cuisine. And after that, we'll have a brief scientific prelude on the physiology of taste before we have Miracle Berry tasting outdoors in the Kirchhoff courtyard. So that's just outside the store. On your way out, you'll be able to have samples provided by Jimmy and Sherry and Hershey's as well. You'll be able to also view the student final projects, which are displayed in the Kirchhoff courtyard. And it's really quite remarkable and amazing and fascinating what these students have learned in the past 3 months, and even in the past weeks that they're going to be presenting to you today. So you will also get a chance to vote on these projects as well. We'll then return to this room for the final talk by Bill Yosses. And then we'll have an Iron Chef finale discussion with esteemed scientists, judges, chefs, and food scientists as well. And you will also have the opportunity to place your vote for the People's Choice Award 2012 Science and Food. In addition, we'll be awarding some grand prizes to the top posters of the science fair. So that's the timeline for today. And without further ado, we'll get started right away with Sherry Yard, who you've all been waiting for. And so I first met Sherry. Thanks to an introduction by Bill Yosses. And so I met her one rainy morning down at the Santa Monica Farmers Market, and she was there bright and cheery, dressed in bright colors, and spreading her exuberance around the market. And she's going to, of course, spread more of that enthusiasm for desserts today. As many of you know, she's the executive pastry chef of the Wolfgang Puck Group and has been a pastry chef at Spago, in fact, since 1994. Also named Outstanding Pastry Chef by the James Beard Foundation, and in addition, the author of cookbooks, too. So, which are pictured here. Desserts by the Yard, The Secrets of Baking. So without further ado, Sherry, thank you so much for coming. We're thrilled to have you here.
Okay, so do I go up and down?
Yeah, so you can go up and down, and Kyle can do that for you, too.
Okay. How do I do it? Okay, poof, there it is, huh? When I first met Amy, first of all, thank you, Amy. Thank you, everyone, for being here all this morning. Wow, what an amazing opportunity to hang with some really brilliant people and get up so early in the morning. So, thank you. Yeah, Saturday night, what was it? Friday night last night? Oh, we do this. Wow, I've never done this before. You do that? Oh, look at that. Okay, so, sorry, I'll spend my whole 15 minutes gas is the gas that happens when you bake, okay? So, okay, let me go backwards. Let me go backwards for a second. So, here's the drill. There we go. There you go. Questions, questions, questions. As a kid, I was always curious. In the second grade, my sister wanted a Barbie doll, and in kindergarten, I wanted a science set. My mother bought it from the Sears catalog, and she hid it in her closet because she thought I was going to blow up the house. I didn't blow up the house, but I just kept asking more questions. Questions on why does the souffle rise? Why do pâtisserie do what it does? Why does the cake fall, and why does it curve in the middle sometimes? And so, in doing, that's better, huh? So in doing so, all these questions, I asked, why, in goodness' name, did Amy ask me here today? When you've had all these amazing chefs and scientists here before me. And then I thought, there we go, I wrote a book. That's pretty cool. And when I wrote this book, the reason I wanted to write this book is because I wanted to share what I learned. Okay, the book is about sharing. There are 12 chapters in the book, plus a 13th chapter because it's a baker's dozen. And in the book, I tried to make people have people understand baking. I then thought about how it all relates to one another, and then we have our family tree. Every single recipe that's a mother recipe, that I like to call it, has a family tree. So in this case, it was easy because everybody loves chocolate, and you wouldn't fall asleep while I'm talking. I decided to do ganache. So what is ganache? It's what we use in pastry all the time. It's a fundamental, and it's equal parts for the most part. Okay, pastry chefs, don't bust my chops here. Equal parts chocolate heavy cream. From those two ingredients, there's so many things that you can make, and all it does is change whether the times, temperatures of the ingredients, right? So in a truffle, it's obviously in the solid form. We melt it down, and we have fudge fondue. We can change our chocolates around. Be careful if you're a home cook and you just say, oh, equal parts. It's a little bit, depending upon what you want to make, a little more heavy cream, or rather a little less heavy cream, a little more chocolate for your milk chocolate and your white chocolate ganaches. I could take sugar, and I can heat the sugar up. There's another chapter in the book called caramel. And so all I do is talk about the different, the metamorphoses of sugar. We could have a whole conversation all day long just about that. But I heat up the sugar, and then I use that as the liquid. Then that will emulsify in with the chocolate. I can then take that base, add egg whites, make a souffle, take the same thing, make a glaze, take the same thing, and make a sabayon by whipping egg yolks up and folding them into the thing. And all the recipes are contained in the book. What do I want to say? The other thing about this wonderful recipe is leave it in your refrigerator, and you don't have to make anything at all. You just stick your spoon in it all day long. Right? That's half of it. I taught my mom how to do it, and I said, what recipes did you make, Mom? And she said, I don't know, I ate everything. So that's good. From there, we then went, okay, if I just put equal parts, rather double the amount of chocolate to 1 part cream, what could I get? What can I do with it? How could it stand up? Certainly I can add butter, which would have more mouth appeal. It melts in your mouth a little bit better. I always like to say this when someone says, my pound cake is the best pound cake in the world. Well, great. What is a pound cake? Equal parts, right? We got 1 pound butter, 1 pound sugar, 1 pound eggs, 1 pound flour. Well, all you got to do, I like sour cream in mine. I like mine with leavener. Well, everybody's grandmother makes the best chicken soup, right? Matzo ball soup, rather. So it's the same kind of concept here. The idea in this book is just to create your own recipes. Okay, so next thing. Not that I want to buy everybody buy the book, but it's a really good book. Now, mind you, that was 10 years ago. 10 years ago when I wrote this book. I couldn't find any real books other than big, fat, scientific books, and I certainly was just somebody who was making some cookies and some ice cream at the restaurant. I've been baking 28 years now. Can you believe that? God. I started when I was 2. No. Okay. So the one thing I'd like to say 20 years ago is that we as pastry chefs were really the scientists in the kitchen. There really weren't, any chef that I worked with, they were, European, they understood the way things worked, they made a souffle, everything was great. But when I started to ask, why is my chocolate breaking? Why is anything happening like this? They would say, go read a book. And I would try to read every book that I had. And I realized that chefs, for the most part, up until the last couple of years, 10 years or so in history, they worked with ingredients that they really didn't manipulate. As pastry chefs, we work with flour. You don't really eat that, huh, on its own. Butter, Can't really eat that on its own, although I do all the time with lots of bread, Rockenwagner bread, right? Eggs, unless you're Sylvester Stallone and you're going to fight somebody. I'm going to the Pacquiao fight tonight. I just have to say that. Okay. And then sugar, unless you're 5 and you like to stick your finger in there. All of these ingredients need to, in order for me to understand my baking and everyone to understand their baking better, need to understand each component of these ingredients, which you're going to go into in a little bit, and how they work together. Okay. So once you knew that, you could definitely be a pastry chef, right? I just threw that up there because I thought, it's so simple. It's no big deal. It's just science. And this cake we made for an event at the hotel. And I thought of, what was the thing that we did that had really the most techniques in it. And so within this cake, we had pâté bombs, where we cooked up the sugar to 235 degrees added over the eggs and created a mousse. And then we rolled fondant over it. And then this piece right here is sugars. And then we did this is actually real and edible inside there, and we poured it over the top, and we had to wait for exactly the right second to bend it around the fondant that we rolled over the thing, and then we did sugar pastillage for the flowers. So yeah, anybody could be a pastry chef. Just put those ingredients together. I always say that we are much more civilized than the chefs back in the day, but unfortunately it's changing a little. Well, fortunately it's all changing. We're all blending together. The lines are blurring. So back to those simple ingredients. Here we are with just a simple pie dough, right? So I would say this, for folks that really always hear this, I just heard this twice already this morning. I don't know, when I was baking, my thing didn't come out right the same way as someone else's. And, here's the thing to understand, is that I like to say that the flour we all know this, it's a solid, right? But then the butter is a liquid, right? We know this is a liquid, do we? Sometimes when I say is butter a solid or a liquid, they say to me, it's a solid. And I say, well, certainly it's a semi-solid, because when you're getting from the refrigerator, but once it goes into the oven, it becomes a gas, yes? So if you have, in a lot of these cookbooks out there, they'll say, break it down to pea size. If you break it down to pea size, then where's your gas? Where's your leavener? Where's your liquid? It's so small that when it goes in the oven, it just does this. It doesn't do puff. Puff, right? And that's what you want. Big, flaky pie dough. Wolfgang once said to me, I want you to make me a pie for Thanksgiving. I said, okay. He came up and he said, no, pie dough, American. I don't want to do European. I said, this is pie dough. But it's all in the way you manipulate the ingredients. When I do my pie dough, I break it down so that it comes down a little more like flattened walnuts. And so it comes out more like this. Unfortunately, can't really see how flaky this one is, but I just looked yummy, so I thought we should all look at that. Okay, good. Okay, so its sister, or its European couture version of pie dough, puff pastry. Wow, look how cool that is. Do you see all those layers up in there? And then you see this. So this is from my book, The Secrets. It's about lamination. So it's how we take butter and we put it in between the layers of the dough. And the temperatures have to be just right? So they're just right as we roll it and fold it. So we get this big dough. We put the butter in the middle. We roll it over. We keep rolling. It comes out to 1,000 layers. Wow, that's difficult enough. Here's where a lot of people go wrong, right here. See these guys? If you go to your average bakery or even someone's home, they don't dry the dough out enough. Because your butter is in there, your butter is your liquid. So what I'll do is I'll take it, bake it off a very high temperature, 400 degrees or so, cut my oven at after about 15, depending upon the size of the product, 15 to 20 minutes, and let continue to bake to dry out. And this dough will stay good all to the next day. I've tricked Wolfgang. Shh, don't tell anybody. It'll stay. You don't have to brush it with cocoa butter to seal it in. You don't have to brush it with anything. It's just beautifully dried out. And then when you eat the perfect millefeuille, crack, and the cream goes, and it's gorgeous. So you see all that? Isn't that cool? Okay, good. All right, so that takes 3 days to do. Okay, so real quick, because I know I'm taking up too much time, but we've got pâte à jus. This is another cousin. Poof, there it is. See him down there? Okay, so the good thing about pâte à jus is, or a great thing about pâte à jus is that you've got it's twice cooked, see? So we got our guy up there, we're gonna cook him up here, then we put him in the little bowl, we add some eggs, we're gonna pipe him up, and then we're gonna cook him up. Same exact concept here, basic baking skills. This, to me, is even a little blonde, but why is it blonde? Because I'm gonna rebake it again. So you have to understand how to strategize for what you're going to make, what you're going to either sell or make for your home or whatever. I actually freeze these suckers. A lot of folks say don't freeze the dough itself. I freeze the dough, let it thaw out before I bake it, and then again, heat. Time, temperature is really, really important. Hot ovens. Poof. So as we know that this is a gas in the middle, right? And then the thing that's going to hold it together is all that gluten around the outside. I have kids that always ask me, why don't we just switch it to potato starch? Why don't we just switch it to quinoa? We'll grind up the quinoa, we'll do this. Well, it doesn't, so you can do it, but you got to play with it, and we're all learning about this whole gluten-free baking, and I'm playing with it as well. But I just love the idea so people can understand that the structure of the gluten is holding the gas in place. Now, okay, I'll get to it in a second. Okay, I brought another example of what happens if you don't. Okay, so we're going to move forward. Now, another version of this, again, we're just talking about the ingredients, right? You've got butter, flour, sugar, eggs. Oh, that's my husband. Sorry. Where are you? He's excited about the Pacquiao fight. Okay, so there you go. All of that stuff, isn't that sexy? So there's your ganache. There's your shoe, a little bit of ice cream you bought at the store, and nobody knows that you did it, you did half of it. But really, really cool. That's sexy, isn't it? Sorry, I didn't want to make you guys that hungry. Okay, so the same ingredients manipulated a different way, and we've got our crepe batter, okay? Butter, sugar, flour, eggs. Small amount of sugar. I like sugar. It's going to give it a little caramelize. And you pour it in the pan, right? So here I got it. Here it is. Simple crepe batter, right? See how thin it is? Nice, right? But it gets nice and rubbery and thick that way, right? Well, what else can you make with crepe batter? Anybody? Popover. Yay! One person answered right. Exactly the same batter. Exactly the same batter. Not one ingredient different. Popover. Why? Why? Oh, I love this. Because I figured this out myself. I thought I was Escoffier. I really did. You know, you do things and it just happens. You make mistakes. So you say, what if we put it in the microwave? I love those what ifs. What if we, steamed it? What if we, whatever. So we happened to have it. We put it in the thing and I figured it out. And that was many, many years ago. And I said, wow, God, I think I know everything, right? I'm ready. It's time to retire. I could take some vacation off. Until I went to France. Then I went to France and I had a cannelé. Anybody? Cannelés? Crispy on the outside, sexy and gooey on the inside, like pudding. Alcohol, one of my favorite things. A little bit of rum, right? A little bit of rum in there. Bakes. Oh, I called up every French friend that I knew, anyone who was an expert. I got the recipes. I did everything everyone said, and what happened? Do we go backwards? Oops. How do we go backwards? That's what happened. Poof, there it is. Because it looked just like this stuff over here. The batter looked exactly the same. So I went back to, and I say, oh, I'm going to get it, and I got it, and I got the recipe down, and I did everything I could, and I got the cannelé, done. Check it off the list. But one day I woke up and said, but why was I trying to fight it? Right? Why fight it? Why not go with it? And I think, to me, this is the essence of me as a baker and what I do and what I keep trying to push the boundaries. As I said, I love popovers, I love cannelés. Let me cross-reference these recipes. Created Excel programs, I looked at pâte à jus, I looked at cannelé, I looked at this, figured it out. Cannelé, you're supposed to heat it up, the milk, so let the batter sit overnight, all these things. And so, I created cannelé popovers. So I think what I'm trying to share with you all here today is that even the simplest baker, even someone that knows about science, Alton Brown, when I did, my book came out, the first book, Secrets, came out, and I did Iron Chef with him, came up to me, running to me with the copy of the book. And he said, I've been such a big fan. You helped explain so much to me. And I said, oh my God, you're Alton Brown. And he said, yeah, but I never knew how to connect a lot of these dots. And I think that's what I'm trying to share with you today, is that we're going to learn a lot about science so we understand how to combine these starches, how to do, that liquid is a gas, and all these poof, there it is. But ultimately, I think that no matter how great the science is, it's the simple pleasures in life that create lasting memories. So that's my story.
So if we could have some lights and some sound, and we have a couple of minutes for some questions from the audience. There's mics up here at the front, so you can just come up.
Handle popover. We had those issues like everybody has with popovers. If you don't try it out, you don't get the gas in the middle, so look at his flat butt. Then you look at this guy, his butt's not in there. You let him dry out enough, and then you open his sucker up. Oh, it's so good. And if you really let it bake longer, I was in a rush this morning. Sorry, I worked late last night. But you see the hole, and you fill it with good stuff, and you still get the pudding on the inside, and it's so good. Okay. That's it. Thank you.
You can stay for questions.
Oh, questions.
Yeah.
Nobody questions?
If there are any questions. There are mics at the front here. Can we ask you to come up?
Come on, say hi.
Hello, my name
Hello.
is Joyce.
Hi, Joyce.
So for my granddaughter's first birthday, I was going to have little goodie bags to give away to the adults, of course, biscotti, and I was going to make them pink because it was a pink party for her. So I decided to melt white chocolate, a brick, but I broke it up and put it on a double boiler. And oh my God, it just,
seized.
yes, yeah. And then I
Yeah.
got online and it said, oh, never try to dip anything with, because I was going to dip these biscottis, turn them pink with food coloring and make them, for a birthday party. So what is that secret to?
So here's the drill. So Joyce was going to make some biscotti. The chocolate seized on her because it was her daughter's birthday. She likes pink like me. I wear it for breast cancer, not Barbie. But so the thing is that the first question anybody asks is, what chocolate did you buy? Second question I'll ask you is what coloring you used, meaning that all of our colorings are oil-based or water-based. So if it was water-based, it's going to immediately make it seize. If you bought some...
I bought it at Surface, so it was a professional color.
Right, but it's still, you have to look on this side, and it'll say oil or water, and you'll see that it has that in there. And the water's going to automatically seize it up, no matter what. The other thing is if your chocolate that you do melt is like, it just stands there like this, you can add a little bit of oil in there or cocoa butter, and that'll help it so that this way it'll do that. But not too much, because then it just gets slimy. So just, I'd say maybe 2% to 5%, depending upon the actual chocolate. Just a whisper. Yeah, but you're past the point. If you're 99%, yeah, I feel like that pilot, the guy in the control tower, that's telling you, yeah. Your coloring had water in it. That's what happened. Enemy, chocolate's enemy.
Can you just go back and clarify what you were talking about with your pastry and how you dry it out again? I wasn't quite sure what you were saying.
So if I'm doing puff pastry at the restaurant, we're doing, let's say, a millefeuille. I put one sheet tray. It's a sheet of parchment or sail pat. The dough itself, parchment or sail pat again. Parchment, I don't like sail pat on top, it's too heavy. And then I put a sheet tray on top. We bake it at 375 degrees for 12 minutes. I remove the sheet tray from the oven. So if you're home, you probably be 400 or so. Remove the sheet tray. Now this is going to get me nice and flat, because when you get them and it kind of goes every which way, even Star-Bar, everything goes which way. So that's going to control your puff pastry. You pull off I have to pull off the parchment, otherwise it gets sucked into the fan, and then I start looking at everybody going, what'd you guys do? Why is the fan going, wah? And so that comes off. I leave it like there for 20 more minutes, sheet tray off. Then I turn the oven down to 325, and I'll go as much as 40 minutes more. And you'll just see, well, I don't have the picture, but you saw, that's exactly what it is. And so what happens is all that butter is just stuck. All the good stuff is stuck to the flour and the paste and all that good stuff. And then all the water's gone. Otherwise, then you sit there and you get squeaky toy, wah, wah, wah. So, does that make sense? Okay.
Off, but we do have a program to maintain.
Yes, okay.
But Sherry will be available
I'm
after,
available.
and so please feel free to come and meet her personally and learn more about.
Thank you, everybody.
For her infectious enthusiasm and curiosity that's very much like what I was trying to convey to my throughout the quarter of science and food. So, Sher, if you can, okay. So thickeners and mouthfeel was one of the topics which, as you've seen from Sherry's lecture, is so essential to desserts and to many other types of foods as well. And so a concept, scientific concept, that describes the resistance of a material to flow or how thick it is termed as viscosity. So this is, of course, essential in physiology. In terms of blood clotting, maybe you take thinners so that your blood is less thick. And of course, it's also extremely essential in many different cuisines from around the world in terms of all these soups, coq au vin, black beans, ossobuco, for example, and many sauces as well. So in the class, we had the good fortune of having Chef Josiah Citrine come in and make this array of sauces in which he demonstrated all of the different ways in which you can thicken or tune the mouthfeel of sauces. And these are all very important in his cuisine, and many of you may make them at home as well. So in cooking, it might be, and baking, some ingredients you might be more familiar with in your kitchen are things like flour, tapioca, or cornstarch. This is typically used, for example, something you might add to a pie filling, such as a blueberry pie, to make sure it's not so runny. In many sauces as well, you can find other ingredients which you might not use in your home kitchen, but you can easily apply xanthan gum, for example, which provides a nice thickness and viscosity to teriyaki sauce so that it coats things better. You can also thicken sauces, of course, by reducing them, evaporating away some of the water, such as in the case of a balsamic reduction that you might serve with strawberries and ice cream. So how can we describe thickening? What's going on at the molecular level? Well, in all these cases, whether by adding additives such as flour or cornstarch, or by increasing the density by reducing your sauce, you're essentially packing these molecules in closer to each other. And what that's doing is that it's creating more interactions between the molecules so that when the fluid flows, it flows more slowly because these molecules have to move past each other in order for the fluid to flow. So more interactions among the molecules equals longer time to flow. In the classroom, this is something the students could actually measure just by flowing some fluid through an inverted funnel, and then they measured the amount of time it took to flow. So obviously you could imagine that if you flow water through, that's going to pass through faster than honey, for example. And an easy way you can think about this as well is that a good analogy is spaghetti. When you have a pot of spaghetti noodles, these noodles get entangled with each other, and so it takes them longer to flow past each other. All right, so where do these molecules come from that we so typically use as thickeners in food and cooking? They actually have very important roles in the physiology of plants and animals. So, for example, in animals, collagenous tissue, such as bones and skin, that breaks down to form gelatin, which is a common thickener. We also use plants, both the seeds, the nuts, and the grains. These contain many different types of molecules that act as thickeners as well. Some of these act as an energy source, such as the starches that are found in grains. They act as a structural role as well, such as the pectin in plant cells. And they can provide hydration as well, such as this gel that surrounds the seeds. This is a basil seed dessert. Last but not least, as we learned in the last lecture, bacteria can also produce thickening molecules, such as the xanthan gum, that is so commonly used in many products, such as salad dressings or teriyaki sauce that you might buy in the store. And in terms of the bacteria, these molecules help to provide a gel matrix which traps in water and nutrients for these bacteria cells. So when I was thinking about the an appropriate cuisine that could tie into a lot of these concepts of thickeners and mouthfeel, I thought that Mexican cuisine was an extremely obvious choice. This is just the example of the xanthan gum, how it makes the fluids much thicker. So Mexican cuisine is very rich in many examples of thickeners, and ranging from corn to beans to rice as well. And so I spoke to Jimmy Shaw and asked him if he would be interested in coming to talk about viscosity. And he was a little dumbfounded. And then I explained to him, well, corn, beans, horchata. And so then Jimmy got very excited about viscosity and mouthfeel. And so we're very pleased that he's able to come with us today to share some stories as well as samples of some of the food that he makes at his restaurants, which many of you may know, the Loteria Grill, which is now expanding rapidly around the Los Angeles area. So, Jimmy, thank you so much for coming.
Good morning. Thank you for, Amy, thank you for the invitation. It's tough to follow Sherry. Okay, so viscosity of Mexican food is so rich, and so often what happens in the U.S. is first of all, Jimmy Shaw, you'd never think I'm Mexican. I was born and raised in Mexico City. I'm the only one of my family who made it north of the border, and so I came to do my little part in changing what Mexican food has been. In the U.S., we tend to get more than anything the northern Mexican food, which is grilled, and it might be a grilled piece of chicken or meat, and then might be accompanied by a salsa. But Mexican food overall is so incredibly rich. Mexico is a huge country, and it has an incredible culinary tradition. It has any number of a variety of regions and altitudes and soils and climates and cultures. The cultural breadth of Mexico is amazing. And so that brings you a huge number of cuisines. And it's a very rich cuisine. And we've only explored a little itty bitty part of it in the US. And to me, it's very exciting to see so many Mexican restaurants coming up, and also seeing kind of broad-based American cuisine being influenced now by Mexican food. How many great Mexican ingredients do we see on mainstream restaurants now? Go to any bar in a fancy hotel in LA, and they've got quesadillas, and they've got huaraches, and they've got garnachas, and they've got all these things that I grew up eating in Mexico City on the street. So when Amy called me and talked about and asked me to come and talk about thickeners, yeah, first it was a little overwhelming coming and talking about the science, because I never studied it scientifically. But boy, I've studied it in my kitchens a lot, and we have so many sources of thickeners in our cuisine. One of the first sources of thickeners for us are seeds and nuts. Pumpkin seeds and peanuts and almonds and walnuts and sesame seeds. Not only the ones that were indigenous to Mexico, but then, for instance, the almonds came from Spain. I often like to say that Mexico is really the first fusion food of the Americas. With the arrival of the Spaniards, you started seeing the combination of these two cultures come together, and it's really fascinating. So in addition to the nuts that we grind up, and toast. First we toast, and that gives them such wonderful flavor, but we grind them and we make them either into paste or powders and use them as the base for so much of our thickeners. We also use a lot of vegetables and fruits. Plantains. When we make mole, our mole poblano, which is one of many moles of Mexico, has 26 ingredients, and the things that we use to thicken them, in addition to some of the nuts, are also plantains and raisins. I love the calabaza, the pumpkin in Mexico, because there's so many varieties of them, but we use not only the seed, but also the meat as a thickener, and we also have some great candies in Mexico that are made with pumpkins. Avocados are a big thickener for us as well. People often don't think of using an avocado as the base for a dressing, for instance. We do an avocado vinaigrette, which is really wonderful and silky, and Mexico has a very deep tradition with avocados, of course. It's the only country in the world where you'll have 2 seasons of avocados, so we have them all year round, and they're such amazing part of the cuisine. Rehydrated chiles. Amy, you were talking a little bit ago about the importance of molecules in thickening, and we often, like when I make our mole poblano, has the 26 ingredients. 6 of them are chiles, which we toast, and then we rehydrate, and they give you so much of not only the flavor, but the body as well. That is the basket that we play with, and just a little part of the basket that we play with in Mexican food. And I would be remiss if I didn't go to corn. Mexico has an amazing history. Oops, sorry. Mexico has a really deep history with corn, and we thicken two ways. We thicken through the starches thickening the foods, but we also grind so much of our stuff, and we have some wonderful tools. Metate, of course, has been in Mexico for centuries. The molcajete. There's a lot of people, there are certain salsas that I love to make in a molcajete and others that I like to make in a blender. And of course a blender. There's no self-respecting cook in Mexico that won't have their trusty licuadora. And in Mexico, there are all these wonderful little shops all over the country where you can go in and with licuadora motors, with blender motors, they can make anything you want. You can motorize a bicycle, you can do anything you want. Mexico has more creativity than you can imagine. And culinarily, we've got huge creativity, but then also, the things that we can do with little motors is wonderful. Really deep connection to corn. It's central to all kinds of religious celebrations and social gatherings, even funerals. And you see its reference. You can't touch anything about Mexican culture until you touch corn. Corn is where all towns start, where all commerce starts, where the traditions and the histories and everything go. And you see it in the pre-Hispanic art, you see it in 19th century art, and you see it today. You go to marketplaces all over Mexico, and the central part of the market is where the corn is put. And the main harvest traditions and the planting traditions, they all center around what the corn gods want. Maíz, deep ancestral link. It's the source of all strength. Even today, 2/3 of all caloric intake in Mexico comes from the consumption of corn. Legend says that it was white and yellow corn that formed the first bodies of humans. And Mother Sustenance God and Father Sustenance God came together, made mankind, gave us nurturing and our nutrition. And what's interesting is that you find this in the not only the Aztec history, but you'll find it in the Mayan history, and you'll find it in all the different groups in Mexico. Will tie everything back to corn. The god Quetzalcoatl works his way into everything. And one of the things that he worked his way into is stealing the grain of corn so he could come back and provide it to humanity. So it's very rich. And Mexico had a really great culinary tradition, well developed by the time of the arrivals to the Spaniards, but then the Spaniards gave us pork. And that was the great thing. We got our lard, we got all the good things that make the combination of the old world and the new world so absolutely delicious. Hundreds and hundreds and hundreds of varieties of corn. You see, it's a huge country, but if you look at, these are the different states in Mexico. Central Mexico, 900 different kinds of corns. And so in as much as we have a huge variety of the plants, we have as many varieties of ways to consume it and use it and have it be part of our lives. This is a great quote from a Zapotec indigenous, an indigenous Zapotecan man. It says, "Cuando se siembra el maíz, when you plant the corn, se echan 4 granos por golpe." You throw 4, for each handful, you throw 4 seeds. Uno para los animales silvestres, 1 for the wild animals. Otro para que les gusta lo ajeno, 1 for my buddies that come and snag my corn. Otro para el días de fiestas, 1 for the days of celebration. Y otro más para el consumo familiar. And the last one comes to me, my family. So before I even have it, there's so much that we use our corn for before I feed myself. So we see corn as a base in atole. Atole is a wonderful breakfast drink in Mexico, and it's I'm gonna show you some transformations of corn in these 3 examples. Pozole. Everybody knows pozole. Pozole is a pork and hominy soup. There are now chicken versions and lobster versions, etc. But it typically was a bird and hominy soup, and of course tamales. So today's menu, I'm going to talk about 2 things: cornstarch. In atole, which is a breakfast drink of campeones in Mexico. It's tough to get up in Mexico in the countryside. And it's a very filling drink, and it's what gets your day started. Nicuatole, what I did is, and you'll see this in the video, what I did is I took kind of a continuum of the use of the starch. So atole is a corn-based drink that if you then continue cooking and cooking and cooking and reduce, you can come up with a couple different things. One is nicuatole, which is a pudding-like dessert. And then tamales colados, and these are really interesting. This is a sweet approach on the thickening and a savory approach on the thickening. And then as you go out, I'm going to give you a sample of our tortilla soup. And our tortilla soup at Loteria is a little bit different than most tortilla soups. It would tend to be a very light broth based. What we do is we actually grind back in tortilla into it, and we do a puree of tortilla soup. So you'll taste that on the way out. Corn is a thickener. I'm also going to show you a little bit about nuts and seeds as thickeners: peanuts, almonds, sesame seeds, etc. And you'll sample a little bit of our mole poblano on the way out, so that you can get a sense of the mouthfeel on it. Okay, atole. It breaks the fast. It is the breakfast of campeones in Mexico. It fills you up. It gets you to start your day. And this is a little bit of, in 30 seconds or less, how you make atole. So we cook the corn, you bring it to a boil, then you move it into a licuadora, your standard licuadora, run it through a china cap, get every last little drop out of it, cinnamon, a little bit of sugar. You can sweeten it with piloncillo, with any number of things, and we did a strawberry paste. So these are fresh strawberries that have been cooked down. Now look at this. This is after about 20 minutes, it starts getting a little thick. And now it gets the consistency of like a hot chocolate, and that's atole de fresa. Okay. Any number of atoles. You can do a straight corn atole, you can do a strawberry, pineapple, chocolate champurrado, it's called when you put chocolate into it. So taking that the exact same liquid, and taking it one step further, we have nicuatole and tamales colados. And I thought this would be interesting because they're less commonly seen. These aren't things that you typically see in, certainly on this side of the border. On tamales colados, what you do is you start by cooking the corn. You set it aside. You heat it up, set it aside. In the morning you come in, you'll put it through a mill, mix it with a little bit of water. You can put a little bit of milk as well. And then you mix that mash, mix it, and then you strain the heck out of it, and you put it through a sieve or a cheesecloth, and you get every last bit of liquid out of it. Then it's slowly cooked, and it's slowly cooked, and you have to move it until it thickens, and then you put it into a mold to harden. Nicuatole, the candy version of this, is flavored and sweetened, and then you mold it and let it set. On the tamal colado side, if you do the savory side, you'll mold it, cut it into squares, put that into banana leaf with a little bit of achiote sauce, achiote-based sauce and chicken and a couple other things, and steam it, and it's an amazing, amazing texture tamal. So nicuatole, check this out. So I took the same atole. Oops, sorry. I need to back up one. Here we go. Nicuatole. Now this is pretty quick, but this is the atole. I used the strawberry version. Look at how thick it gets. That's about after 40 minutes. I made a corn and cinnamon version as well, and that's about 30, 40 minutes into it. Then it gets that thick at about an hour. And you mold it, and very quickly it comes out like a paste in loaf form. What I ended up doing with this is I cut them up, and I put a little of confectioner sugar and cinnamon, and the mouthfeel of these were just absolutely incredible. I have a little bit here, and we'll try to cut it up and give you a sense of what it's like. But that's nicuatole, and to me it's really fascinating to see the texture on this is amazing. It was just absolutely fabulous. Okay, so then doing the savory version of that, tamales colados. This is a recipe that I learned from my culinary mentor, Diana Kennedy. If those of you who aren't familiar with Diana, she's an English woman who went to Mexico in 1957 and has documented food like only an English person can. She's got, she would travel Mexico in this wonderful pickup truck, and it has a cot in the back and a gun, and This is a lady that can get posada or lodging in any part of Mexico, and gets people who would never give up a recipe to give up any recipe that she could want. I don't know what she does, but God bless Diana Kennedy. Tamales colados. This is a recipe that I learned with her at her house a few years ago. And so this is the same kind of thing. In this case, I did a savory one. And after about an hour or so of just cooking at very slow temperature, you mold this as well. And it'll set very quickly. And through the speed of video, you pull it out, and the texture of it is amazing. It's a little bit like tofu. That's an achiote sauce right there. We put a little chicken, a little more achiote. Fold it up and steam it. About an hour later, they come out, and you cannot believe the texture of these. You didn't see that, these are really good. It's just basically corn, a little bit of lard, and salt, a tiny bit of milk. But the texture on those is really, really, really amazing. So that's the use of corn as a thickener. You saw atole, you saw the Nico atole, and then you also saw the tamales colados. So what about mole poblano? Everybody's always talking about mole poblano. And what does it have to do with peanut butter? At the farmer's market, next door to me at the farmer's market, at my first little restaurant I opened 10 years ago, right next to me is McGee's Nuts. And every day I walk by this wonderful, the peanut butter section that they have there. And one of the things that I love about it is up on the top, you've got the molecules not moving very much, right? It's just what's the ingredients in peanut butter? Peanuts. And I love the fact that on the top that they're in solid form, but really they're a liquid, right? That's peanut butter. And if you think about peanut butter as a base, we use nuts in our cooking. And so if you were to warm it up, it becomes, if a good silky peanut butter that's been well ground, warmed up, if you add a little bit of chiles to it, conceptually, pretty good stuff, huh? So making mole poblano, these are all of the ingredients to go, or many of the ingredients to go into our moles, into mole poblano, or any number of moles or pipians in Mexico. The pumpkin seeds, the peanuts, the almonds, the sesame seeds, the plantains, these are the raisins, dried chiles. But we also get some of our thickening in mole from cornstarch as well as wheat starch. A good mole poblano will have toasted tortillas in it and toasted bolillos, or French bread, which you then grind up and put back into your mole, and it's what provides the body of that sauce. So we have peanuts, almonds, walnuts, sesame seeds, plantains, raisins, dried chiles, and the tortillas and the wheat. That's the mole poblano. So Loteria, this is how it comes out. These are two of our tacos, our chicken and mole poblano and our chicken and red pipián. Pipián is another type of mole. So you see how the chicken and that really nice, beautiful, thick sauce sticks onto those proteins. And other examples in the middle, and this right here is our cream of corn and chile poblano. So there we're getting the thickening through the corn, a little bit of the cream, and the chile poblano that's been blended into it or pureed into it. Beans. Beans. They're the most amazing thing. Cook your beans with epazote. Epazote is an incredible herb from Mexico, and we use beans anywhere from frijol de olla, which is bean in its whole form with a little bit of stock, all the way to frijoles refritos, which is simply a mash of beans. It's been reduced until it has that thick consistency. But we make a kind of enchilada called enfrijolada, where you're taking beans in a nice broth, blending it in your ever-trusty licuadora, and it's the basis for your thicker sauce. Down on the bottom left is our salsa de chile chipotle. It's a tomato-based sauce. We do tomatoes, then we caramelize a little bit of onion and garlic, and mix that with chiles chipotles that we've toasted up a little bit, and that thickness is simply because there's no thickening agents other than it's a reduction, if you will. And our tortilla soup. This is a tortilla soup that's a puree of of tortilla. Do I need this? Okay. Oh, my tortilla soup. And then it'd be terrible I'd be remiss if I didn't talk about horchata, of course, and horchata can be made with almonds or rice. In our case, we make it with rice and cinnamon and milk, and we soak them overnight, come in the morning, and blend them and put them through a sieve, and you get a really beautiful, thick texture. And of course, flan. The difference being that in flan we use egg as the thickening agent. And that's it. Muchas gracias. I'm very happy to say that in July, on July 1st is our 10th anniversary. And we're going to start the Summer of the Taco. And for me, it's a lot of fun to be able to look at the ingredients in Mexican food and always try to figure out how you make that beautiful mouthfeel that we have. It's an amazing cuisine, and it's fun to see that people are accepting it more and more. And Amy, thank you for the invitation.
Thank you so much for coming.
Thank you.
All right, so we have time for a quick question or two if the one is very fast. As we get switched up.
Perfect.
All right. Well, if there are no questions, then, one question.
I want to ask you what the leaf was that you wrapped around the...
Banana leaf.
What was it?
It was banana leaf that you put it on a grill so that you soften it up, you steam it a little bit, and that makes it pliable. And but you have to be able to you have to put it over fire first. You can do it straight on a flame, and just pass it quickly so that it changes color very quickly.
Great presentation. You made me so hungry.
Thank you.
I have a question for you. Well, first
Yes.
of all, I love your restaurant. It's delicious.
Thank you.
My first question is, do you put pork jus in your salsas? Because I could just drink that like nonstop.
No.
Okay, I did know.
No. The things that require pork have it, and the things that don't. No, but our salsas don't have it. No.
They're so good. They're
Thank
so
you
good.
very much.
And then the question is, when you were making the corn, what's the difference between that and polenta?
Well, polenta would be a little more of the grain. This is simply, what I was doing right there is
Right.
simply the liquid. It's not in any way the whole grain, but basically it's the same principle.
Is it the same technique? But like, you say that's just the water. Is that just the corn liquid? Like, do you take
Yes,
like...
remember that I put it through our blender.
Right.
And then we strain the heck out of it. So it is just the liquid, it's none of the fiber.
Okay, well, thank you so much.
You're very welcome.
Well, let's thank Jimmy once again for
Thank you very much.
fascinating tour. So we have just a short prelude before the break, because what would food be without taste? We've seen this highlighted in the lectures this morning, and also especially by chefs Rene Redzepi and David Chang, who really focused on deliciousness. So in the kitchen, as many of you know, we manipulate taste in various ways by adding salty, bitter, sweet, sour, or umami compounds to the foods that we make. And there's a reason that we like these flavors. In the context of evolution, we need to be able to maintain an electrolyte balance in our body, so we crave salt. Bitter is an excellent way to stop eating, to tell us to stop eating something that might be harmful or toxic. Sugars, of course, well, who doesn't like to eat sweets? And then, of course, acid is both the small bubbles that bacteria produce, and as well as the compounds they produce that make food taste sour, can also be important for us to know. And then umami, this meaty flavor we learned about extensively from David Chang, glutamic acid, or MSG, can signal food that is high in protein. So how does this all work, though? How do we taste? Well, we know on the tongue there are these tiny little bumps, and these little bumps actually contain tiny taste buds inside of them. And the taste buds contain a group of cells, and you can see that this is the width of a piece of my hair here, so it's similar in dimensions. So that's how big this is, but if you go down to an even smaller scale, you can see that they're on the cell membrane, which is very, very thin, that there's these proteins, and these proteins are receptors. They're like the key for the locks that are the taste molecules that we eat that are in the food. So it's this amazing architecture of taste that enables these tiny, tiny molecules to elicit a response within these cells that then signals to the brain, and we can perceive something as being sweet or sour or salty. So this is the canonical map of, that I learned about in school, which is actually not true due to more modern research. Molecular biology, for example, has provided this insight into this revised map on the tongue, which you can read more about. And so not only, though, can we change the way things taste by adding molecules in, we can also manipulate our taste buds. So I don't know if anyone has done a flavor tripping experiment before, but that's what we're about to experience in the break. There's this special berry that was termed the miracle berry, discovered in West Africa, that contains this protein which will bind to the sweet receptors on your tongue. So it binds to the sweet receptors on your tongue and has the effect of making things that are sour taste sweet. So basically, sour things can activate the sweet receptors. So we have generously from M-berry these proteins in the form of small tablets that you will take on your way out, and there will be a panel of interesting or foods that will taste unexpectedly delicious that you can eat as you are perusing the student posters. So last but not least, you're going to take treats by Chef Shaw and also Sherry Yard as well, who has brought kindly some samples of what they've both talked about, as well as your M-berry sample. And please pick up your voting card when you're looking at the student posters. We will be awarding the People's Choice Award, so write the number of your favorite poster on a card, give it to one of the volunteers who will be milling around in the courtyard. And we will convene back in this room at 11:30 on the dot so we'll then continue with the program. So please enjoy. Thank you.
You have to vote.
Oh, you have one already.
You let it melt? What do you do?
Exactly. So usually we put.
It tastes sour though.
I know, but it's good. It was interesting.
Oh, okay. The orange is a tortilla soup and the brown is a mole.
Pero ustedes hacen mucho con maíz también. Han de tener algo parecido en algún lugar.
Welcome back, everyone. Welcome back. A quick announcement. There will be volunteers that will come up and down the aisles to collect your People's Choice voting cards. We're tallying them up, and then at the end, we will reveal the winners. So in the meantime, I have the great pleasure of introducing friend and colleague Bill Yosses today. Bill and I have had the pleasure of working together over the past several years on lectures centered around science and desserts. He's been involved with the Harvard Science and Cooking class as well, and he's a master pastry chef. He has such fine attention to detail and exquisite sense of taste that can become apparent in his books that he's written, such as Desserts for Dummies, A Perfect Finish, highly recommended, and has a long history of working in top-notch restaurants in, around the country, especially in New York City as well, under such luminaries as Thomas Keller and Daniel Boulud. He's currently the executive pastry chef at the White House, where he is also heavily involved and a strong proponent in initiatives towards healthy eating with the First Lady, Mrs. Obama. So without further ado, Bill, thank you so much for coming. It's such a pleasure to have you here.
Thank you. Thanks. Thank you very much. Is this my PowerPoint here? Great. Thank you, Amy. Thanks for having all of us here and for this incredible program on science and food. I really enjoyed watching Sherry's introductory session, and the Mexican one made me so hungry. So luckily I got to taste some of those delicious recipes outside. I hope you enjoyed them as much as I did. So we will try to bring together a lot of different elements from the course and talk about not only how desserts or cooking in general connects with science and how much help it has been to us as chefs, but also we'll do a couple of quick demos of what you might call modernist cuisine or avant-garde cooking, and the sort of things which got myself very interested in the science side of it. And just as Sherry was saying in her presentation, how we, as chefs, we were, when we were starting, we were just told, well, that's the way it works, go read a book. But there were no books. And until Harold McGee wrote On Food and Cooking in 1991. And Amy and I were talking earlier about some of the work that preceded that, and there were actually some things published in 1969. So happy 40th anniversary modernist cuisine. Who knew it had been around that long? Today, I titled this talk Sweetness and Power. It's actually the title of a book also from a much earlier era, 1959, not that much earlier for some of us, but Sweetness and Power was a book written by Sidney Mintz. It is about the sort of the influence of sugar in Western civilization. It's more of political and social aspects of sugar, how it was developed in the Far East and then came to India, and through India into the West, where it was prized as a spice and brought by Arab traders and used just like cardamom and cinnamon and sprinkled on foods as a spice. It was not until later in the Renaissance that actually dessert as a separate course was conceived and served, and that sort of really launched the popularity of sugar. And when the businessmen of medieval Europe learned that they could grow it themselves in Sicily, and many of them were Venetian traders, grew it in Sicily and then the Canary Islands, and finally, as we all know, grown in the Caribbean, primarily in Jamaica. And that began the triangular trade of sugar grown in the Caribbean, shipped to England, made into either molasses or rum or raw sugar, and then continued into the slave trade down into Africa and back to the Caribbean. So it's quite a powerful and terrible, really, history of what is a very sweet and pleasant part of our lives. We're finding out how little of it we should be eating. If you have read the Richard Lustig article, Is Sugar Toxic? I'll tell you the answer, it's yes. And it's a fascinating and really convincing indictment of sugar. So why am I talking about that? I'm a pastry chef. Well, I think we can still eat it in small quantities, and the idea of healthy living is not to perhaps be strict monks and too hermetically sealed in our beliefs, but to have a wide variety of foods and to eat them in the proper proportions. So I'm very proud to be part of Mrs. Obama's team at the White House, which is fostering and out there trying to talk to people about healthy eating, what can we eat and what can we understand about what we eat, and that ties in very well with today. And Amy has been a great source of inspiration and knowledge and teaching for myself and the students in the class, as she was at Harvard when this program, the whole idea of food and science sort of germinated. So thanks to her, and thanks to welding this idea of health and knowledge, knowing what we eat and what happens to it, to the nutrients when we absorb them. So that's a long introduction for a title, but we'll go on from there. So I will talk now about what I do, and that's one of the more fun things. You're in the very famous backyard of the White House there, where we have a beehive. Myself on the left, and Susie Morrison, the assistant pastry chef at the White House, and we are happily covered up there in bee suits because we're about to open up that hive where there are about 70,000 bees, honeybees, very docile honeybees, by the way. And last year we took out about 225 pounds of raw honey from that hive. That is also part of Mrs. Obama's program to talk to children and not so young people about the garden, which is next to that beehive, and how we use that to teach children in the DC area, and actually from around the country, who come and help us plant those vegetables and help us harvest them and learn about where food comes from and how it goes from the ground to their plates, which for some of them is a revelation that it comes out of the ground, not the supermarket. So once it gets to the plate, if you're having a very fancy dinner party, it looks like this. So a beautiful picture of the old family dining room in the White House. This happened to be set up for the Seder dinner at Passover. An incredible, wonderful group of people from the campaign and from the Obama administration who come there and celebrate Seder on that beautiful table. One of the things I'm going to talk about is the importance of cooking as a civilizing force, and certainly the idea of gathering around, whether it's a table like that or a primitive campfire where you were communally cooking your food. Cooking is really one of the sources of our civilization and our ability to live together. So speaking of living together, this is one such convivial moment. I'm sure there are some that are not so convivial, but this was preceding the state dinner on the South Portico of the White House, and Prime Minister Cameron and the President and First Lady and Prime Minister Cameron's wife had a moment just of relaxation before they went through the official dinner. Back to the science, this is something that myself and my team make every year. It's made out of white chocolate. So as Sherry was saying too earlier, when we first started in this business, you have to temper chocolate. It means you go through temperature changes in order for those molecules to assemble in a way that it's rigid. If you don't do that, you can melt it and put it back together, and it doesn't hold up like this. It won't keep these fine shapes. These individual little cornices here are shaped like roses. I don't know if you can see it there. But all of this is extremely defined. It's based on the James Hoban architectural drawings for the original White House, and it is completely to scale. So how can we do that with something that's a liquid when you melt it and it goes back into being a solid? That's the kind of thing that Amy and her team teaches us chefs. Why does that happen? So in order to know that, we have to understand a little bit more about chocolate. There's the garden again with some children from the neighborhood who came to help us plant. Crystallization is what is happening here, and when it comes to that chocolate, and what we're going to talk about further. And what that means is whether it's sugar, as in this case, where we've melted this sugar, and so it was liquid again, went back to a solid, and it crystallizes around this slice of cara orange. So we can make beautiful decorations and make beautiful effects in the kitchen due to a lot of effects that none of us understand as chefs, although we're starting to. So cooking has taught us not only those scientific concepts of how things crystallize and how they form, but as we were talking about earlier, the civilizing effects of cooking, it not only had civilizing effects, but it had effects on our evolutionary growth. For example, it gave us a wider choice of ingredients because some things you can't eat unless they're cooked. It neutralized, cooking or putting things on fire neutralized toxins. So if there's some things like cassava, which feeds a good part of the world in South America, is actually toxic when eaten raw. But when it's cooked, it's nutritious. It kills heating or cooking, kills bacteria, and that also makes more nutrients available to be absorbed by the body. So all of these things, it's thought by some evolutionary biologists, cooking are actually helped humans become who they are. Because by all of these aspects, we're able to grow a larger brain. And would that we were used it better these days. But in any case, we have it. So how do chefs benefit from this? Well, chefs seek to manipulate matter, as Sherry was talking about those cannelés and how they were, that sort of perfect classical cannelé was crunchy on the outside and that soft crepe batter was unctuous on the inside. But it can also be, if you like the crispy part, maybe you can let it grow and, as she said, not fight the natural tendency of that crepe batter to overflow and form those kind of beautiful pinnacles. So we, as chefs, want to use science and our knowledge from the scientists to manipulate matter and turn it into liquid, foamy, crunchy, unctuous, smooth, crystallized. And more than that, if for savory chefs, they're fusing the muscle fibers into collagen and using what's called the Maillard reaction, which is kind of the caramelization of meat when you put meat into a skillet. The Maillard reaction is that very flavorful and perhaps unhealthy effect that takes place on the outside. So that's one of the really fun things about this 40th anniversary of modernist cuisine, I love to keep repeating that, is that chefs began to think about what flavor was, what deliciousness was, and particularly what caught their eye and what caught the guests or the restaurant goers' eye were the textures. So textures that had never before been seen, at least deliberately, they may have happened accidentally. All kinds of textures were created. And some of those were created by Ferran Adrià, who's sort of like one of the foremost practitioners of this kind of cooking. There's a lot of others, and he has influenced a lot of others. I think very few have done it to the level that he did and continues to do at Alicia. So here's an example of a beet foam. What is a foam? Well, as Amy would explain to us, it is they are bubbles encased in liquid. We all see bubbles all the time, but usually they disappear quite quickly. That's because, as she would explain to us, the pressure on the inside of a small bubble is larger, higher pressure than on a larger bubble, so they tend to regroup, form larger bubbles, and then pop. But for a chef, that's a problem, because I have to serve maybe a table of 12, and I want this foam to be on the plate. I've made the foam, and I've got 3 plates finished. I still have the other 9 to do. So the practitioners of modernist cuisine, such as Ferran, came up with some ideas for making foams like the one here, and some of the other textures which show gels and gelation, which we'll talk about in a moment. And then I just wanted to briefly go over what are the size of these processes, this foam and these molecules that are forming it. Well, talcum powder is 1.5 microns. 2 microns is that, if this is the diameter of a human hair, as Amy showed you earlier. So that's the level, the mesoscopic level on which these reactions are taking place. So emulsions, foams, and gels are what we're going to talk about. And to go back to foams, they are integral to light desserts, and we're going to show you now how a liquid becomes almost a solid. Like that foam can be made by adding my hero, Ferran. That foam can be made by adding a simple addition of lecithin. So it's a natural product that we can add to our liquid here, which is watermelon juice. Wonderful. Okay, now we got it. Okay. If we were just putting the immersion blender into the watermelon juice, we might have some bubbles, but they wouldn't last. But what we're able to do is build up a nice suds there, and it's a suds that will last. If you're doing this sort of on your own, the technique is to just leave part of the blade slightly out of the liquid. The rest of it should be immersed, and so that blade is just grabbing a little bit of air and bringing it into the watermelon juice, and then the lecithin has a chance to formulate sort of that very symbiotic relationship where the bubbles last. I was reading about a another teacher at Harvard, Emily Dresser, who was working with foams. Foams are of interest to people in many parts of science and industry. They even make some metals out of foam. But in this article, it was in the Harvard magazine in last April, I believe. She's a postdoc student there. She created a foam that lasted a year. It's an edible foam. So this is the kind of thing that ice cream makers are very interested in. Not that we want to, keep food around as long as possible, but the thing is that those bubbles, which are created here, the longer they last, the more delicious and the beautiful texture that you have. So what she used in that recipe was called sucrose ester, so sucrose being sugar. What an ester is, you'll have to ask Amy, because I have no idea. But with sucrose ester, she made a foam like that, put it in the refrigerator, and a year later it was still there. So foams are the kind of thing, this will last probably a good hour. Plenty of time for a chef who's working on several plates or a service in general. Didn't take very long, and for us to be able to do that in really an efficient way. So next thing, we said we were going to talk about foams. The other thing I want to talk about is emulsions. Emulsions are a dispersion of one liquid in another. The most famous is mayonnaise. When it comes to mayonnaise, so that's what we just did. Lecithin, as in egg yolks, is what we used. My favorite picture of a foam. So emulsion of chocolate and water. So emulsions are dispersion of one liquid in another, mayonnaise being the famous one. You put oil into your vinegar, egg yolk, and mustard, and whisk that together. What happens is the molecules are dispersed and suspended, and what is working for them there is the protein and the lecithin of the yolk. Well, for pastry chefs, it's very interesting to use that process for chocolate mousse. So when we make a chocolate mousse, typically we would add egg yolks and heavy cream. Both are delicious. I have nothing against them. But we've learned, of course, through by using a lot of fats and cholesterols that cell damage occurs, especially in old people like me. So that it's kind of interesting to find ways to make a delicious chocolate mousse without all those saturated fats. So chocolate itself has a fat, which is cocoa butter. It is an unsaturated fat, so not quite as damaging as a saturated fat. And in order to do this sort of experiment, I need to talk to you a little bit about what chocolate is. So it may encourage you to know that chocolate is a fruit, so healthy eating. Chocolate fruit. It was a surprise to me after 15 years of working with chocolate as a professional pastry chef to know that that's what chocolate comes from. Beautiful cacao pods, primarily from Mexico, by the way, to tie back into our mole discussion earlier. So a beautiful cocoa pod, which when broken open looks like that. Inside are the seeds. Those seeds are then fermented and dried, roasted, and that's how the chocolate flavor comes about. So what we need to know in order to talk about emulsions is that chocolate is a blend of cocoa butter and cocoa mass, which is separated out of those seeds. So the problem with that emulsion, as our questioner this morning said, when I put that drop of water in my chocolate, it seized. Yes, it did, because you put that emulsion out of balance. But there is a way to do it in which it will work, and we're about to show you. This is the recipe. So for that emulsion of chocolate, cocoa mass, and cocoa butter to stay together and to make beautiful, lovely chocolate like here, you have to add something to make it emulsify. When we made the old chocolate mousse, we add yolks and cream, but if we can replace those proteins in the yolk and the cream with gelatin, we can have the same effect. And there we can actually make a chocolate mousse out of chocolate and water. Now, this is, again, I'm kind of like going back to the early days of talking about food and science, and this is actually in Hervé Tisse's book. Hervé Tisse is one of the French proponents of this kind of cooking, and Hervé Tisse talks in his book about replacing the yolks with gelatin. I think we're just about on the limit of temperature here, but let's see what we can do. So now we have water, chocolate, and gelatin in here. We're going to mix it together. Okay, now we have that. We want the emulsion to take place. So what we do is cool it down. When we're cooling it down, the chocolate is crystallizing, word from earlier, around the bubbles. So when we crystallize the chocolate, we have the emulsion and the crystallization at the same time, and we can make a really lovely chocolate mousse with just water and chocolate. I'm going to continue that in a minute, probably after we're finished, because I know we're running close on time. We'll continue that, and you'll see that it becomes a very smooth ganache, as smooth as any ganache made with cream. And the difference is that you really have the chocolate flavor. It's a pure flavor of chocolate, which is unadulterated by those other flavors. So just the water. It's kind of like a moussey egg cream, if you're familiar with egg creams. Okay, went too far. So one of the other sort of processes that we have done in modernist cuisine is using gels. Gelation is one of the processes also which is studied in physics for how do these molecules come together, how do they stay elastic, what is their viscosity. As we learned earlier, we can measure that viscosity. So today I made a very viscous substance, and we're going to do something that is known as spherification. And so it gives, again, a texture that we normally would not be able to achieve in the kitchen. So here I have coconut water. So it's a kind of a popular healthful drink these days. I added a little bit of sugar and also a little bit of what is called algin. So algin is made from algae, and so it's a kind of a thickener. In this water over here is calcium chloride. Doesn't sound that appetizing, I know. It's what you throw on the sidewalks these days to melt ice, but probably you don't know what I'm talking about out here. So it's not that nice, but it does effectively melt if it melts ice, because as a salt it lowers the melting point of snow. Another concept that's foreign. Anyway, so lucky that you don't know what it's about. Okay, we have that. What that does is make a cross-linking. So it's a polymer which cross-links, meaning those two things have to come together in order for the gel to work. So the algin and the calcium chloride, when they come together, they immediately cross-link. It's what they call self-assembling properties of these two ingredients. And what happens is then you have these little, and maybe we could get the camera again to come up here and get it, because they're pretty small to look at. So you have these beautiful little spheres of coconut water and with a jasmine flower, because we're trying to stick with our locally sourcing. These jasmine flowers are from right out that door. And delicious. It's simply wonderful. So we'll do one in real time here. We take the coconut water here, and since it has the algin in it, it's a little bit viscous, as you can see. And we'll cover it a little bit on top with some more so we can actually make a sphere. Okay. I put a little extra algin in here because I want it to happen right away. if we, I didn't want to wait since I know we're on a time. And then, so this goes here and forms that, can you see that all right? It forms that wonderful kind of sphere, which will hold up, again, several hours. What actually happens is that the process of that cross-linking continues, and after a couple hours, it will penetrate to the center, so that you'll have more like a gummy bear than you do a sphere. But for a few hours, it's liquid in the center, so when you bite into it, it's like biting into a grape. So you have this wonderful splash of flavor in the center. So spherification, one of the great processes of modernist cuisine. To just jump back to foam, and I'll wrap it up with this, one of the favorite tools of chefs these days is called the EC foamer. These basically whipped cream foamers, but we put a lot of different things in them. In this case, it's pineapple juice with cream, which normally pineapple juice might break that cream, and we'd have kind of a cottage cheese effect. But in this case, we put just a small amount of xanthan gum, which we spoke about earlier, that gel that forms around those bacteria. So what we're able to do is to make a nice little foam like this, but which is very nice to eat just like that. But not content to leave well enough alone. No chef today and no lecture on food and science would be worth its salt if we don't make some smoke and mirrors. So we're going to freeze that mousse in liquid nitrogen. .300 degrees below zero or something close to that. As soon as it comes into the, as soon as it hits the air, of course, it's boiling. So it's boiling at below zero, but it's also evaporating. What this is just nitrogen. It's harmless. It's an inert gas. 70% of our atmosphere is nitrogen. So it does no harm to to what we're making, or to ourselves when we eat it. It may do harm to this tablecloth. I forgot to move it onto the cutting board. There we go. Kind of a little, like when you leave your iron on a shirt for too long. So, as I said, one of the aims of this kind of cooking is to make new textures, and what we could do is just put it in here for a short time, and then it would be soft in the center. After that much time, it's like a meringue. So, I think we covered everything, and almost in time.
Questions for Bill. There's
yes.
some time for some questions. Please come up to the mics and speak into the mics.
I just wanted to know if he could put the chocolate mousse recipe back up so we could take a
picture
of it.
Oh, sure. Yeah, it's fantastic. You have to. It's in grams, but we can do a quick, if anyone's uncomfortable with that, we could...
And there was actually another request for a recipe, and if the chefs are okay with it, we can simply post those recipes on scienceandfood.org.
Oh, great. There's a great way to do it. Yes?
I have a question. Inasmuch as you're working with the First Lady on health issues and food, and no one's really spoken today about where our food comes from. And in the morning we heard about the first lecture was mostly wheat-based, and we went corn-based.
Yes.
And those two ingredients have been modified by agriculture in our country. And I wonder if there's any discussion about not only what foods we should eat, but the quality of foods that we should be eating, and how American industry has, with the oil lobbies has really changed the quality of the foods that used to come from the United States?
In my opinion, there's no more important question than what you just asked. This is a crisis that is facing us, and it's one of the purposes of this kind of course is for us to understand where the food comes from and what it does when we eat it. So diabetes, obesity, these are problems which are huge in our country, and because of the way we eat and where things come from. So it is a huge question, and the whole Let's Move organization, which Mrs. Obama started, is about where food comes from, and that's why we have the garden, and we try to encourage a healthy way of growing food. You may be familiar with the Michael Pollan book about the botany of desire, or Omnivore's Dilemma, and in which he postulates that an evolutionary biologist looking at our planet might say that wheat and human beings are in direct rivalry, and that wheat is winning. So in terms of evolution, wheat has made itself delicious. It has most of the nutrients we need, and it has kind of gotten us all as humans to plant 3/4 of the planet has wheat on it, and also our government devotes about $20 billion as subsidies for wheat. So in terms of two species that are sort of vying for control, wheat is winning. But the problem is that many of those wheats are produced in a way that are not healthful. Our whole agricultural system is pouring too much nitrogen into the soil, which then forms runoff into our waters and streams and chokes them with algae. So it is a huge and crisis level problem, and one that I thank you for bringing up. But we all need to work on that, because the way food is produced now we've been doing that for 60 years. We're not going to turn it around in, a couple of classes. So the more you know about that subject and the more you're active in it, the better off we all are. Yes?
So, do you think that's why modernist cuisine is evolving the way it is? Because you're talking about making a mousse that we've traditionally made a certain way, but now with very limited ingredients, which some might say is healthier, or, alternate ingredients, or just less impactful. You don't have the chickens, you don't have the milk from the cows. So, why now? Why is modernist cuisine and this kind of chemical cooking the way we are now evolving or developing as it is?
It's a great question. I think it is. It's the reason why this auditorium is full, because we are all concerned and interested, and it's the kind of thing which we have to be concerned with in a sort of in a careful way or in a health way. But it's also, one thing I like about this kind of cuisine is that it's celebratory, because whatever we do with food, it has to still be delicious. As chefs, we have to make the food fun. We have to still use this sort of theater and drama. That's what cooking, and that's what fine cooking started as and still is. So the modernist cuisine, I think, is a very appropriate blend with the quest for more healthful cooking, because it's about understanding what we eat in both cases.
Well, on that note, I would like to thank Bill again for a wonderful display of desserts.
Thank you.
Thanks. So the program is soon coming to an end, but we do have the one final last part, and we're just going to have a quick scene change here, and we'll turn off the projector lights, turn on the room lights, and I'll introduce the esteemed judges who have been evaluating the student projects. So we have Professor Stephanie White, who is a professor in the Department of Integrative Biology and Physiology here at UCLA, an expert in language acquisition, and wonderful friend and colleague. So Stephanie was partnered with Professor Dan Blumstein, could stand up, who's also professor here at UCLA, the chair of the Department of Ecology and Evolutionary Biology, and also author of the cookbook, Eating Our Way to Civility. We have then Jeff Potter, who is a local food and science aficionado and expert, the author of Cooking for Geeks, which is a wonderful resource you should all check out if you haven't already. He's also featured on Monster Food, so you may have seen him on TV crafting 100-pound donuts. And he was partnered with Professor Felix Schweitzer at the back, who, if Felix, please stand up, professor in Department of Neurobiology in the David Geffen School of Medicine here at UCLA, and expert in basically understanding how neuron cells communicate. All right, then we have our chef judges to complement our scientist and food scientist panel here. We had Chef Jimmy Shaw, who we're all familiar with. Thank you, Jimmy. Wherever he is. And then Chef Josiah Citrine, the chef and owner of Melise Restaurant in Santa Monica, and also the co-owner of the Lemon Moon Cafe. Josiah, if you could come up onto the stage. So Melise, as many of you know, currently holds 2 Michelin stars, and Josiah is also the author of the cookbook In Pursuit of Excellence. So these judges, our esteemed panel of expert judges, have been evaluating the student projects just as you all have as well, and we thank you for your votes. They're being tallied as we speak, and we're now going to hear from the judges on what they thought were the most outstanding projects. So, Stephanie, why don't you begin? Which project did you like the best?
My favorite project was having to do with putting strawberries in vinegar help keep them more sanitary. So this was a project by Gary and Ayako, and Gary's girlfriend always takes these strawberries that you probably get from the farmer's market. You're really excited. If you're like me, you just put them in your mouth right there, but actually think about where strawberries come from, how close to the ground they grow, and then they get, I think yeah. Good. Thank you. So anyways, in the kitchen, Gary's girlfriend was putting them in vinegar as a way of washing. And so as a project, Gary and Ayako decided to test the scientific validity of this approach, and they took strawberries and put some in water and some in regular old white vinegar and some as a good control in nothing, which is what I eat at the farmer's market. And then after they dipped them in there for the same amount of time, they streaked them across agar plates, which of course bacteria love, and they waited and saw how many bacteria grew on the plates. And in line with their hypothesis and supporting the girlfriend's lore in the kitchen, the one with the vinegar had the fewest number of bacteria and also the least type or least variety of bacteria. So it's lending validity to this hypothesis. Now, as good scientists, they then re-questioned their results and noted that it was just one type of agar plate, and so maybe they'd actually selected for the nastiest bacteria, I don't know. But so I really liked that insight and planned for follow-up studies.
And Jeff, what about you?
Well, I did really like the strawberry one as well, and I thought that they did a really good job of kind of doing a couple of iterations, different trials, and then the future questions. But for me, I got to say, the microwave one, Tammy's quest to understanding what was going on in her microwave. And the great thing for me was when I asked her, so where did you get this idea from? She said that there had been a class experiment having to do with different sizes of blocks of cheese and what melts fastest, and that she disagreed with what happened in the class. And so for me, it's like, okay, here's somebody who doesn't agree with something in the world. She goes out and says, okay, I'm going to try to figure out what's going on here. I'm going to do an experiment and see what happens. And so she took and did it a couple different ways. Her hypothesis was with the different sized cheese blocks, which from what I understand, apparently the larger one is supposed to melt faster than the smaller one, because the probability that the microwaves in the oven will actually hit the larger block is higher, just because it's got a larger area, larger volume. But she, as an electrical engineer background, was thinking, well, there's different areas of the microwave, and maybe what we actually tested for in class was that where the block of the particular cheese was just located in the oven in such a way that that particular block of cheese got more radiation from the oven and melted. So she came up with a couple of different ways of looking at it. One was just to take and layer cheese across the entire platter and not not have it rotate in the oven and just run it for different times to see if the cheese would actually melt and burn at different points in the microwave, and it did. And then she also did a test where she took hot dogs and put them in the oven at different places and zapped them for the same amount of time and looked at what the internal temperature was. And based upon where the hot dog was inside, the different temperatures, different points. And her takeaway was that when you put something in the microwave, you actually want to put it on the edge of the platter and have it rotate around. So it has a higher chance to actually pass through a zone inside that microwave that was actually under more radiation there. So I liked her enthusiasm. I liked the approach she came up with. I liked that she questioned something she didn't agree with, and she went off and, like a good scientist, got some data and looked at the results and came up with a good model and a good theory. So she's got my vote.
And Josiah, from a chef perspective, what do you think about these microwaves and strawberries? What were you looking for in a project?
Well, I find it all very interesting. As Sherry said, I kind of come from the back in the day when the chefs just did this and, okay, go read a book. We knew how to make things work, but we didn't know the scientific background. So I find it very interesting the last 10 years really digging into this and learning about it. Strawberries is very interesting. So maybe we'll start dipping them in vinegar, try some balsamic vinegar. The microwave is interesting because it's one of those things that, we use a little bit in the restaurant to heat certain things that we want to heat delicately. Or sometimes we fall behind and we need to heat some short ribs really fast.
I was wondering.
I
always wondered how you guys do it.
It works. No, sometimes you're behind. We try to do it nice and slow, but actually it comes out really nice and they actually get really soft. And
so you're saying the microwaves are useful?
Yes, very.
Okay.
Yeah, very useful. And then I enjoyed the Analysis of Flavor by nitrous oxide. We've been doing a lot of work with different teas and different timing and infusions, and it's very interesting to see all the data. I found that all of the projects had so much great information and so much data, and I need to have someone come work in my kitchen with me so we can have this happen every day on what we're trying to learn. So any of the students want to come down?
Excellent. And Stephanie, Jeff, do you have any comments on the nitrous oxide infusion project?
I thought it was a shame that they couldn't use vodka for their samples because, I'm sitting there talking to them and thinking, well, you tried putting your leaves in water to bust open the cell walls and see, how much damage was done. But really, ethanol and vodka are great for this. Apparently something about not being able to serve students alcohol, I guess. Shucks.
21 under.
All right, well, without further ado, and keeping you all in suspense, the winners, please. So in third place, we have, and the prizes are all generously donated, I have to say, which I mentioned already, but this is an Umami Burger gift certificate. You can eat $100 worth of Umami Burgers. Wow. And this prize goes to Ayako Zabalaga and Gary Kong, washing strawberries with vinegar. Congratulations. Are Ayako and Gary here? Come on up, guys. All right, so they're going to come up and retrieve their umami burgers, which should keep them busy for the rest of the day. All right, and in second place, we have the envelope, please. A Whole Foods gift certificate, very valuable for students. Let's just present this to Ayako. Congratulations, and Gary, enjoy your burgers. Well done. And this prize goes to Josh Liu and Chris Dunn for nitrous oxide infusion. Chris and Josh, please come on up. So you can put this to good use and do more experimentation for the UCLA Cooking Club, which these guys are also keenly involved in.
They also had an outstanding pointer.
Yeah.
It was a fork.
Yeah. Do you have your pointer with you? Your pointer? Okay. All right, and in first prize, the grand prize, goes to, dun da da da. Oh, what did they get? The prize is, yes, the prize, first of all, the prize, because it is a very generous prize donated by Breville. It is this fantastic amazing juicer, which is very useful in here in Los Angeles. The variety of fresh vegetables and fruits available. And so the first prize goes to, and I should note too, this person also was the People's Choice Prize as well. Tammy Chang, what's really happening in my microwave? So, and as Jeff had mentioned, Tammy is an electrical engineering student here, and so she really brought knowledge from different classes as well that she learned about microwaves and the theory to explain how they work. This is all for you. Yep. And the juicer. Congratulations. All right, so on that note, thank you all kindly to the judges, both those that are on and off stage. And for this stimulating discussion on science and food, and thank you all for coming to this 2012 first inaugural series of events. So stay tuned for more to come. Please, more to come next year. Please take your trash, put it in the bins, and we want to leave this place sparkling clean. So thank you all again.